Okay, so now let's move on to the final question, question C. On Wednesday, she loaded 3Y red shirts and Y blue shirts. Okay, so straight away let's create the table again. So we have for red we have 3Y, and for blue we have Y. Okay, and we have store 1, store 2, red, blue. So red is 3Y, blue is Y. Okay. And at store 1 she dropped off some red shirts and no blue shirts. Okay, at store 1 she dropped off some red shirts. Let it be X. Let's assume she dropped X red shirts and no blue shirts. Additionally, she picked up some green shirts. At store 2 she dropped off all remaining shirts, and the number of red, green and blue shirts dropped off are equal. Okay, so here a new color of shirt comes into the picture, green. Okay, let's assume that there are Z green shirts. So what she does is that at store 2 she dropped off all the remaining ones. So the remaining red shirts would be 3Y minus X, blue would be Y, and green is Z. Okay, in store 1 it's 0 for green shirts. Now what are given here is that of all these shirts, at store 2 she dropped off all the remaining shirts, and the number of the red, green and blue shirts dropped off are equal. That means what we have here, I'll write it at the top. What we have here is that 3Y minus X is equal to Y equals to Z. That's what it's trying to say here. And we have to determine the percentage that will green. Okay, so if here we can see that if from the second two terms we can see that if Y is equal to Z, so we can write Z as Y. So this reduces the number of variables here. Instead of 3 variables we have 2 variables. Now let's see if we can do something about the X. So the basic formula would be to determine the green shirts, the percentage of green shirts would be green shirts divided by total no of shirts multiplied by 100. So it would be green is Y, and total would be 3Y minus X plus Y multiplied by 100. So normally we would be so this is the answer, not exactly the answer, but this is the formula that we have for the answer. So now the main issue what we have here is that we have this term X, because of which we are not able to find the exact percentage number. So is there a way to fix this X so that if you can write everything in terms of Y, then we will be able to cut it off. For that it's very simple. Again, look at this one. Look at the first two terms. The first two terms we can write it as 3Y minus X equals to Y. So we can write X in terms of Y. So this implies 3y minus y equals to x. This implies x equals 2y. Because it's being said that the number of red, green and blue shirts were equal. So I'm actually making it too complicated. Simply, okay, let's just go step by step. That would be much more systematic way to do it. So since we found out that x is equals to 2y, now let's substitute x equals to 2y in this equation here. So we have 3y minus 2y, which is equals to y. So we have y, y and y here. So basically we can now replace here the place okay, let's take this to the next page. Okay, so previously we figured out that 3y minus x is nothing but is equals to y. So we can, in the denominator, we can replace this thing as y plus y plus y into 100. Now it's very simple. Y divided by 3y into 100. You can cancel y. So this implies we have 100 by 3%, which is nothing but 33.33%. So the answer to the question here is that of all the shirts dropped off on Wednesday, determine the percentage that were green. So all of these three are equal. So green is also equal to y. So the percentage of shirts that are green is nothing but 33.33%. So that's the answer for the third question.